Hello guys. So in this class we are going to start dimensions. Units all over. Previous class units we studied. Now dimension. Before studying dimension, what do you mean by dimension? Dimension, the question which I asked in the class. So dimension is very simple. See, the power to which fundamental quantities you all know, it is universal quantities, fundamental quantities must be raised in order to express the physical quantities are called dimension. What they are saying, just simple. Let us take a fundamental quantity, for suppose length. This fundamental quantity are rising to power, here rising with some power in order to express it physical quantities. Not so. For suppose see, if I have length 2 times of length, then I will write like this. 3 times of time, then I will write like this. This is basically called as dimension. Just simple. For fundamental quantities, we are raising its powers. I will give one example. You will clearly understand. Okay, now see, I will take one example. Let's say velocity. Velocity is equals to displacement divided by time. Right. Now displacement measuring length. Time measuring seconds or time. Let's say time only. Time. Length you can write L, right? Physical quantity L. Time T. Now I can write like this. This is dimension of velocity. Now length rise to some power +1. Time rises to some power -1. This is called your dimension. Dimension is very simple. Physical quantity is rising to some power. That's it, your physical quantity. Dimension. Now we will discuss some dimension more. Like for example, one more thing. Let us take let's say acceleration, force. Force is equal to what? Force is equal to mass into acceleration. Right. Now acceleration is equals to what? Velocity by time. Velocity dimension you got here. Now one more time is there. If I send this above, what happens? It will be like t. This one like I got acceleration. Now for mass it is just m into acceleration. See, here mass rises to power 1, length rises to power 1, time rises to power 2. The way we are writing powers are fundamental quantities. That 7 fundamental quantities are there now, which is mass, length, time, electricity, luminous intensity, temperature, to their powers. That is called dimension. Okay, now super. Now see, there is one more definition here. Such an expression for physical quantity in terms of fundamental quantities is called dimension equation. These are called dimension equations of this. For suppose see, this is dimension equation of force. This is dimension equation of your velocity. This is basically a dimension. Dimension means just simple. We are raising it fundamental quantities to some power. In universe everything is made up of that 7 fundamental quantities. If you know that 7 fundamental quantities, that's enough. By using that 7 fundamental quantities rising to power, we are writing dimension. So simple concept. So simple. Now let us see similarly dimension. See, dimension can be 0 also. This also can exist. See, m0, t0, l0. This also can exist. And dimension always you write in bracket, like this bracket, m, l, t, like this bracket. It may be 0, 1 or anything, but bracket is compulsory. Now let us see dimension of some things, like methods to finding dimension of physical quantities and coefficient. If you solve this, you will get a clear-cut idea in your brain. Now area means what? Area means you all know, length into breadth. Area is equals to length into breadth, right? sorry, length into width, sorry, length into width. Now we measure length in L, width also measure in L only, right? Width also measuring in length only, right? Then it comes L square, fundamental quantity rising to some power, or you can even write like this: M0, L2, T0. Both are fine, and bracket is compulsory. Now area of circle, pi r square, pi is constant number, r is that length, radius. Circle, r is what? This is circle, this is radius, right? R. This is only length only, right? This one also length only. So we can write this also as same, r into r, radius into radius is equal to length into length, and again same bracket. Now what do you mean by volume? Volume is equal to height into length into width. Volume is equals to height into length into width. Here comes your 3 cube, right? 3 cube means what you can write? M0, L cube, T cube. Now volume of sphere. It is like 4 by 3 pi r cube. Now this is constant, then what remains? R cube means what? Again length, again same L cube, again same L cube. Super. Now comes piston. Okay. Now let us see what do you mean by density. Density is what? Density is equal to mass by volume. Density is equals to mass by volume, right? Density is equals to mass by volume. Mass, physical quantity, mass measure in M. Volume, L cube. Now what you can write? M L cube or M to the power of 1, L to the power of 3, T to the power of 0. Easy concept. Super easy concept. Right? Now let us see for velocity. Velocity is equal to what? Displacement by time taken. Displacement measuring again distance. Distance means length. Time measuring time only. Time. Now what comes? T inverse. Now you can even write it as M0 L1 T. Nice, right? Now let us say linear momentum. P is equals to mv, mass into velocity. Mass, you know, m, v you just derived here, v, write it. You got for this also dimension, which is very easy concept. Now after this, I think you are taking notes. It's good to take notes in the class. Now let us see for force. Force is equals to ma, Newton's law. Mass into acceleration. Mass measure in m. Acceleration means what? Acceleration is equals to velocity by time. Velocity is L T inverse and T, which means total dimension of acceleration is this. Now here we have mass plus acceleration T, L T to the power of 2. Here you got force dimension. Super easy, right? Super easy. Now let us see similarly for power. We just need our definition of any quantities, definition of anything. We can write dimension. Okay, now power means what? Power. No, for this you only calculate. For power and work, try to calculate. Try now. Power and work. I will say for this one, you must try for this one, because power, it is a little tricky. Let's see you will do or not. Work is equals to what? Work is equals to force into displacement. Force you got here, force you got here, force you got there. M, L, T to the power of minus 2. Displacement measure in length only. Then your total outcome is M, L square, T to the power of minus 2. Very easy. This is only dimension. We are that 7 quantities. We are writing power for the 7 quantities. We are deriving. So simple. That's all. Nothing complicated. Very easy. Like eating peanut. Okay now. Now let us see for some other. This is normal thing. Area of circle, value. These are simple things. Now let us see similarly for some dimension of angular quantities. Angular, which makes some angles now. That kind of quantities. Well, let us derive our dimension. Oh, angular displacement. Angular displacement is equal to what? Area divided by radius. Area divided by radius. Area measure in length. Radius measure in length. No, sorry, not area. 1 minute. Not area. Arc. Angular displacement is equal to arc by radius. Arc measuring length, radius measuring length. So what happens here? This L cancels each other. Then it will be M0, D0. This is dimensionless quantity. We call this as dimensionless quantity because everything is 0. Everything is 0. Fine. Now, similarly, let us see angular velocity. Angular velocity, which we represent by W. This W, not W. It's W. W is equals to angle by time. W is equals to angle by time. Angular velocity is equals to angle by time. Angle, no quantity is there, which means 1 by only t. So you can write it as t inverse, or you can even write it as m0 L0 t inverse. Super. Now similarly, angular acceleration. Angular acceleration is represented by this symbol, and angular acceleration is rate of change of angular velocity. Same. Now angular velocity is dimension is this one. Now here also one time there. Now what will be your final answer? T to the power of minus 2, or you can write this 2 and this one. Okay now, super. Now let us see for torque. Torque is equal to what? Your torque is equals to force into perpendicular distance. It's like opening a door. Whenever you open a door, you apply some force. Okay now it will move from one point to other point, but perpendicular distance is covering. Super, right? So torque is equals to force into perpendicular distance. Force, you know, just now you write what is for force. See here, for force, ml t something, ml t to the power of minus 2, ml t to the power of minus 2 into perpendicular distance. Distance is again length. Then total final quantity l square t to the power of minus 2. Now you try for this last one, gravitation constant. Try now only. Try gravitation constant. Gravitation force is equals to G into m1 m2 divided by r square. We want is this, which means you can write G is equals to F into r square divided by m1 m2. Force dimension you have, r means radius is again length. This one you have, mass mean m1 m2. Try it. Your final answer will be like, try this L cube t minus 2. Final answer for this one. Try. If you solve this one, you will get this answer. Try it. Yes, 100% sure you will get this one. Super. Easy? Yes, easy. Don't worry, we will go easy. Just for 1 week, one chapter, 1 week, it's more enough for us. We will cover everything. So this is your dimension. Now, if someone asks you again, Sad. Why sad, man? What sad? What is sad? No sad. If you don't understand, tell me. I will make your life happy, not sad. No sad. No need reasons to enjoy. We are ourselves company. It's easy. It's easy. Yes, it's just easy. The thing is, no one make you feel the physics. Now I am making it's okay, man. Dimension. Now see, dimension. Okay, man. Okay. We will discuss this in WhatsApp. Now let us finish this. Now dimension. If someone asks again, don't tell we don't know, and don't ask them what is dimension. Just tell we will raise power of some quantities, physical quantities. Now let us see to convert physical quantities from one system to other system. System means what? There are three systems. Yesterday we discussed three systems. That centimeter, meter, something systems, MKS system. Remember? Remember. Now we need to convert two systems. Like from MKS, let's say we are converting system from MKS to CGS system or FPS system. We need to convert from this system to this or this to this by using dimension. Let's see how can we do. This one. Topic is conversion of physical quantities from one system to other system. Now before one thing, your Nu is equals to constant. Yesterday we discussed this one. Nu is equal to constant. Everyone knows Nu is equal to constant. N is a number, U is a quantity. Everyone knows. Now if you compare two things, it will be like this. Just simple. 5 centimeter is equals to 0.05 meters. Nothing changes. Just this number, this quantity changes. But both values is same. Okay, now I can write like this. Now what? Now this is number. Number is constant. Now it is unit. Unit means it will have some dimension. Unit means, for suppose unit 5 meter. If I take 5 meter, so meter is what? 5 into mass 0 L1 T0. Right? So similarly, which means unit. This is unit. It has some dimension. Which means it is general unit. It has also have some dimension. I can write like this. Oh, sorry. One second. In the place of A, I am taking B, and let's say this one C, and here quantity 2, and again M1, M2, A, L2, B, T2, C. See, just simple converting this 0.0 centimeter. 5 meter is equals to 500 centimeter. 500 centimeter. And 500 centimeter is also again same. 500 is equals to centimeter. First mass 0, length centimeter. That's I am writing here general form. To find a last final formula to convert from one point to other point. Okay, now super. Now if I want to convert N to if I want only N2, then I will send this side. If I want only N1, then I will send this one this side. Now let us see for N2, only N2. Only N2 is equals to N1 into M1 divided by M2 into A, L1 divided by L2 into B, T1 divided by T2 into C. Can I write like this? Yes, of course I can write like this. Just simple. What I did is I just send this one that side. It comes like this. Now I am removing these commons. m common, t common, and writing it powers. Writing its powers. That's it. It is your final answer. This formula you need to convert from one point to other point, one system to other system. You will use this formula. How will you use this formula? Let us see by one example. Example. Now convert gravitational constant from CGS. CGS means centimeter gram second to meter kilometer. 1 minute. Centimeter gram second to meter kilogram second. Okay now. Okay. Now let's see conversion. G is equals to what dimension? You all know. M inverse L cube t to the power of minus 2. Okay. Now you have one formula. Just now you derive formula. N2 is equals to L1 by L2 to the power of A and M1 by M2 to the power of P and T1 by T2 to the power of C. Now we want this A, B, C numbers. A, B, C. It's just here. This number, this number, this number. That's it. Now your A is equals to minus 1. One second. M always comes first. Remember, M always comes first. M always comes first. A is equals to minus 1. B is equals to 3. C is equals to minus 2. Minus. Why confusion? I will write this. No confusion. I will write. Wait. No confusion allowed. M1, M2 into A, L1, L2 into B. Now it's fine. Now it's super. First of all, we need to convert from CGS system to MKS. Always remember what they are given first. It will comes in your numerator, and last this will comes in your denominator. CGS. N1 here, N1. Okay. Now let's do this. How to do? Okay. First of all, centimeter. CGS system. CGS meter measure in centimeter, and centimeter, and your mass measure in gram, right? Mass measure in gram. Length measure in centimeter, and your time measure in seconds only. CGS over. Now denominator MKS. Mass measure in kg. Length measure in meters. Time measure in SO. Now values of A, B, C. A is equals to minus 1. B is equals to 3. C is equals to minus 2. Fine. Now just simple. We will convert these values. How convert these values? How? 1 gram is same. Now 1 kg is equals to 1000 grams. Everyone agree? 1 kg is equals to 1000 grams. Similarly, centimeter 1 meter is equals to 100 centimeters. Now remaining is yes. These both get cancelled. Okay. Now let us convert this one and let us see what will come. Let us convert this one and see what will come. This C, this cancels. This C, this cancels. Now remaining is your 1 by 1000 to the power of minus 1 and 1 by 100 to the power of 3 and 1 to the power of minus 2. Now your final answer will be, if you solve this, you will get your final answer 6.67 into 10 to the power of minus 11. This is your gravitation force, and when you convert to MK system, it will become this. We are just converting gravitational force from CGS system to MKS system. For CGS system, we will write this CGS on numerator and this MKS denominator. When we write MKS denominator, gram is CGS and here is kilogram. 1 kilogram is equals to 100 grams. We will cancel this gram and gram. There comes 1 by 1000. And here above centimeter, below meter. So if you want to cancel that one, how can you write centimeter divided by 100 centimeter? Centimeter get cancelled. 1 by 100 to the power of 3. Simple case, you will get your final answer is 6.67 into 10 to the power of minus 11. This is like gravitational constant, right? I don't know what it is, you have to tell me. Super, right? Simple things need simple calculation, no complicate. Okay now? Okay now? You have to do this for many. I will give you worksheet. You have to finish it. Okay. If you don't understand, tell me, let me know. We will discuss that one only again. If you don't understand, let me know in comments. First, if you didn't understand that one, let me know please. Someone, anyone. No one. At least if you understood, tell me. If you don't understand, tell me. What's the doubt, man? Super. Okay, thank you. Okay. Now, shit. As my battery is dying. Now let us finish this one. Understood, bro. Super, bro. Now, to check dimension correctness of physical quantity. By the help of this dimension, you can even derive some formulas also, and you can check whether it is right or not. How to check it is right or not? Here comes your new topic. To check dimensional correctness of given physical relationship. You have derived one formula. Whether it is right or wrong, you can say by using this dimension. How to say? I will tell you, don't worry. See, here to check this correctness, you have one formula. X is equals to A plus or minus BC square plus or minus square root of D is F. Now someone will ask, do we need to remember this? No. This just I am explaining. See, this will be something dimensional. This will have some dimension. And this is equal to this full. This is equal to this full. Then you know what happens now. This dimension is equal to dimension of this one. And this dimension is equal to dimension of this one. Dimension of this one. And this dimension is equal to dimension of this one. Individually it will equal to this one. This is individually equal to this. This is individually equal to this. This is individually equal to this. Let us see one example. If I take example, you will 100% surely understand. Example, V is equal to U plus AT. This is your famous example, velocity formula. Now velocity is what? This one velocity. This is also velocity. This is also velocity. Same, right? Now, but here you have acceleration and time. Acceleration is what? Acceleration means t, this one. And you have into time 1. Now 1 get cancelled. Again you will get this one. Which means this is again equals to this, right? Which means individually V dimension equals to U and V dimension equals to AT. Super. By this you can check correctness also. See, like this you can check correctness. Any formula, if it has plus, minus, anything, you can easily check it, whether it is right or not. So, when you are in exam, not in your NEET, in CBSE exam, if you get final answer, check if you are confused it is right or not, then check one's dimension. If dimension is right, then your answer is 100% right. Super. Now, let us see the next slide. What is this? As a research tool to derive a new relation. Just now I said by using dimension, you can even derive new relation, new formulas. How? I will tell you, don't worry. if one knows the dependency of physical quantities. See, this one is important. Dependency of physical quantities on other quantities. On other quantities, if the dependency is of product type. Oh, just simple. If someone knows how much dependency is physical quantity, if I am deriving, I want to derive one formula, and I am saying that some physical quantity is dependent or not. If I get this some quantity is dependent, then I can easily derive equation. How? Let us see one example. You will 100% understand. Now, time period of simple pendulum. Time period of simple pendulum is a function of mass, length, acceleration due to gravity. Now see, this is on physical quantity, this is on physical quantity, this is fundamental physical quantity, and this is derived physical quantity. Now physical quantity is dependence, which means this simple pendulum is depend on mass, length, and acceleration due to gravity. Dependency. Three dependence. It depends on three, which means dependency exists. Dependency exists. Let us derive formula. Let us derive formula. How? Very easy. Summa, very easy. If you learn this, you will enjoy it. See. Now simple pendulum. Simple pendulum means time of simple pendulum. Time of simple pendulum is depend on mass, length, acceleration due to gravity. Acceleration due to gravity. Let us say A, B, C. Okay, now acceleration due to gravity. If I remove this constant, I can write it as K, right? K. Okay. Now mass measure in M only to the power of A. Length measure in L only to the power of P. Now gravitation is equals to LT2 minus Z. Fine, super, gravitational constant. Now here if you see this side M is equal to 0, L is equal to 0, only T exists, and this side M is equals to A, L is equals to B, and LZ T to the power of minus 2 of Z, so that you can add this both. See, sorry guys, see. Now you can add this both, right? You can add this both, and you can write B plus C. Just compare these both sides. Enough. Just compare these both sides. Here M value A is equals to, here it is 0, and here minus 2C. T value minus 2C. Here 1, which means your C value becomes minus 1 by 2. C. Now you got A value, C value. Now we want our B value also. B plus C. See this one. L. B plus C. L. B is equals to 0. Which means B is equals to minus C. Which means minus C minus of minus 1 by 2. What will come? It will be B is equals to 1 by 2. You got C value, B value, A value. Substitute in this, you will get your answer. How? See, very simple, peria simple. How? Inverse direct proportional to M to the power of 0, A value 0. L to the power of B value is 1 by 2. And your G to the power of C value is minus 1 by 2. Minus 1 by 2. Enough. You got your answer. Now if we remove this constant, then we can write it as 2 pi for constant, gravitational constant. Ignore it. Now M is 0. Now here only this one is there, and G1 is there. So if I remove this half of, just simple, see, don't introduce, sir, here minus 1 by 2, here plus 1 by 2, just simple, I am sending this to denominator, it will become minus. Very simple. I know, very simple. Ayyo. 1 second. Now, if I remove this both, it will be like this. Right? It will be like this. This is your gravitation formula. Time period of simple pendulum formula. T is equals to 2 pi square root of L by G. L by G. See, very easy, summa easy. Okay, so that's it for today. We will meet in next class. Okay, thank you guys.